Hey everyone, so I guess we're at the time to start the seminar here, and I'd like to welcome you all here. I'm Professor Whitcomb, a new professor here at Cornell in the Systems Engineering program. I started here in mid-August, so I don't know many of you. I recognize a couple of students from my class this semester. And so what I'm going to be presenting on today is the context and the basis for a study that I conducted over a 3 or 4 year period several years ago, in which I'm continuing today, to try to understand what kind of competencies, meaning what kind of knowledge, skills, abilities, and behaviors do systems engineers need to know and be able to do on the job as systems engineers, as practitioners of systems engineering, as well as what kinds of knowledge, skills, and abilities should you be learning about systems engineering while you're in sort of education training position out there. So first off, I want to start a little bit with a brief summary overview of myself, again, because I'm new here. I started my career as a undergraduate in nuclear engineering at the University of Washington, Seattle, Washington. I then went on to be join the Navy. I was in the Navy at the time, so I was assigned to a nuclear submarine where I served on the USS Scamp, a submarine where we spent our time in the Atlantic Ocean and the Mediterranean. Didn't get to see an awful lot because we're underwater, but it was a great experience. But I really wanted to be an engineer. I did like being in the Navy, so I stayed in the Navy, became a submarine engineer, where I went into designing, building, and repairing submarines. So I went from a submarine base in Connecticut to a submarine shipyard in Connecticut for my first job, doing new construction of submarines there in Groton, Connecticut for the Electric Boat Company. I was on the government side, where I was overseeing parts of the contract and the construction of these submarines, making sure that the government was getting their money's worth out of what's going on as far as the sort of construction and repair of these kind of systems. I later went on to other jobs doing more computational design of submarines. I think that's where I kind of like things even more. I really was impressed by what it took to put these submarines together and get them working, but I really liked working at the computational analysis. So I used to do computational fluid dynamics, look at propulsion system design, and then integrating the whole system design, which is where I started to learn about systems engineering, and that the sort of the integration of all these things to put them together to make them work as a whole is what really got me interested in systems engineering. It was kind of the start of where I became involved with systems engineering. After my Navy career, I ended up at MIT, teaching in the Ocean Engineering Department, teaching naval architecture and marine engineering, of course, looking at this from a submarine perspective, but also for all kinds of ships and aspects related to vessels on the water and systems in the ocean. I then went at MIT to the System Design and Management program, which is a master's program in systems engineering. I worked there for a couple of years, and then took a position at the University of New Orleans, where I taught naval architecture and marine engineering once again. And in 2005, went to the Naval Postgraduate School. I was enticed by them starting a systems engineering department, an actual department in systems engineering, which I always wanted to be a part of. So I was able to be there from the start in the development of that. And so I was at the Naval Postgraduate School for 17 years. I was a professor there. Was appointed eventually as a distinguished professor of systems engineering. I was chair of the systems engineering department. Recently retired from there in August and came here in August to the program here at Cornell. Very excited to be here at Cornell because I really like the way that Cornell has not just a focus on one kind of system. They've got all kinds of systems in sustainability and food security, energy, social-technical systems, beyond just the sort of military systems that I was working on. I'm also a fellow of the International Council on Systems Engineering and a fellow of the Society of Naval Architects and Marine Engineers. For those of you who are PhD students, how many PhD students do we have in here? Okay, I'm also editor-in-chief of the journal Systems Engineering, so if you're looking to publish some of your work, as you probably have to in order to be able to finish your PhD program, we have a nice journal in systems engineering that you can publish. So I'll kind of put in that plug there. So let me start a little bit at the beginning here. I like to take some kind of approach and talk about what are we talking about with systems. I think that's kind of interesting. This book here, Rescuing Prometheus, was authored by Thomas Hughes, a professor of history at University of Pennsylvania, probably somewhere around 20, 30 years ago. But he tried to look at where did this idea of systems engineering, where did that come from? And one of the quotes he took out of part of a study that was published was to look at this as system as a special arrangement of matter, and they were looking at it from a defense perspective, the air defense systems. At the time in the post-World War II, in the U.S., there was a lot of concern about Soviet bombers coming in with nuclear bombs and trying to drop them on the United States, so they were developing air defense systems that could actually try to detect those. And they wanted to be able to detect them automatically, not just have people looking and trying to find them, but have radar was developed and operated in World War II, so they wanted to put radars out there and try to get this whole screen of things so that they could see these things coming before they would have time, so they had time to do something about it. So he started talking about these things as systems, as organisms that were governed by the whole, that you couldn't just look at one part of it now, you had to look at things as a whole. And what really determined what you're looking at is the function of that system. So they said that really the defense system is kind of like an organism, an inanimate organism, but still somewhat of an organism that has sensory components, communication facilities, can be data analysis, centers of judgment, and directors of action and effectors to achieve some defined purpose. And this was published in 1950. So this was very early look at, before they even had systems engineering, this was the first study to try to look at how could you look at these kind of systems. Now looking at some more modern kind of evolution, I'm going to start here with a quote from Rear Admiral Grace Hopper from the United States Navy. Anybody ever heard of Grace Hopper before? Yeah, as you're a computer scientist, you might know that she worked to develop one of the first computers that were ever developed. She was the third person ever to operate some of these first computers. She was the one that in a documentation or journal first coined the word bug and actually took the moth that she found in the computer and taped it into her notebook to say that she had found a bug in the computer. It wasn't working. She's also credited with having invented the computer compiler, the first compiler, as well as the computer programming language COBOL. So I really like her quote there. Life was simple before World War II, and then we had systems. And what was she really talking about? I think she was alluding to the fact that once we had computers, and we could actually do a lot of this sensing and decision making and response, that this is something you could take, in some ways, take a human out of the loop and have a system that would operate as an organism. And this made developing things and engineering things much more challenging than it used to be, when you could put things together and then you had it, so you humans did all that stuff. So this was, so I'm showing at least in cars here, starting out as early as I could find, 1908, Model T Ford. Then pulling an advertisement I found for the 1951 Ford, had automatic transmission for the first time, so they were really pushing this idea that now you didn't have to change gears, but they're really advancing this as a structure of an object that you could see the boundary of. When you're looking at the car, that's pretty much the boundary of what you're looking at. Of course, the highway infrastructure that went into that and people and traffic, these were systems things that maybe they weren't looking at the time. But when you start looking at a car today, I mean, you're looking at something that's just multiple computers, processors in there, some 50, 100, a couple hundred processors on some cars today with all kinds of possibilities around self-driving, artificial intelligence, having to be aware of your surrounding for various features in the car, not just on the car, but also among vehicles and communicating. And so it's just become very complex. And car manufacturers now, I kind of took Ford here because I served on some panels with one of the directors in systems engineering at Ford Motor Company, and he's just saying that they just got to have more people that understand systems. And it's not just a car anymore. It's an interconnected piece of a network and a node on a network. And he's trying to get more people to understand that so he can hire the kind of people that have the skills that he needs to be able to do that. I just also pulled something from Car and Driver magazine, and a recent one, that no matter what you're looking at with a car, there's just so many computers in it that it's not just a car anymore. Looking at their chart here, 40 to 45% of the cost of a car these days are these computers and the networks and the electronics that go in it. When you consider that this wasn't even something that was in a car, say 30 years ago, now it's getting close to half the cost of the cars in these sensor and computer systems. And then going beyond this into just the automobile itself, but looking at the overall structure of what you're doing in the system as far as internal to the vehicle. This is a study by Deloitte that was published recently. But now they're looking at the car as part of the system. So you can see that there's the cloud, there's they say the LTE mobile base station. I suppose they could have put down there without being LTE, that this is also 5G or whatever they're using. But there's vehicle communication. There's got to be communication among different aspects of the infrastructure and people and parking. So this whole thing is a very system of systems context. And it's not only with automotive systems as an example, but it's going across areas. I kind of grabbed some things from various Cornell websites on climate, energy, food security, health, all kinds of things out there that provide this kind of context on what you need to understand. What you need to know about developing systems and what are those kind of competencies that are necessary for that. So what I want to do is cover a very brief background on competencies, my motivation as well as the sponsors of my research motivation for studying it, show you some examples, and then talk a little bit about the implications to education. Showing this book here, the Systems Engineering Competency Assessment Guide. I'm one of the 3 main co-editors of this book that's going to be published in January by Wiley on Systems Engineering Competencies and put out there. This month's issue of Insight Magazine, it isn't published yet, but it will have an article that I co-authored on how to use competencies to develop aspects related to job descriptions in the workplace as well as aspects related to education. So I'm going to start just by defining, what is a competency. It's not a word that perhaps you've heard an awful lot. When I started doing this, I wasn't even sure what competencies were. But the competency is just that observable, measurable pattern of skills, knowledge, and abilities and behaviors. So they're characteristics that an individual needs to do their job. Now, competencies are usually allocated to the job. You need competency to do the job. People develop competence to be able to do that job, and people have knowledge, skills, and abilities and behaviors to do that. So once you can define what the job needs, you can match people to those. How do those people get the competency and the competencies through education and training? So if we can understand what the basis of that knowledge, skills, and abilities are, then we know what we should be educating to, and the companies know what they need and how they need to define what they have, what they need to get for people to work in those jobs. Now, frameworks or models are just collections of competencies, typically with a theme around them. I've been working on systems engineering competency models, but there are hundreds of competency models out there in the world, whether they're industry-specific or domain-specific, like there's engineering competency models, accounting competency models, there's just all kinds of competency models out there that companies use to help define what they need for their workforce. They provide a roadmap for career growth, and then organizations use them and tailor them to be able to get models internal to their company to know what kind of things do they want their employees to know and work on. And once you have these competencies, you can start to assess people on how well they do their job and how well you need them to do their job. And when you're proficient and become more proficient, you can be promoted and have a basis for that on some kind of an objective basis. Not just the abilities of the technical areas, but your behaviors from an emotional intelligence perspective and dealing and working with other people, things like that. So these are all defined in these competency models. Now, I just want to provide a little bit on sort of the background of why am I looking into systems engineering competencies? Well, these are a couple of lists of official job titles in the U.S. government. I'm sticking with the government because many companies don't like to release their list of people and what they want in their employees. But the Office of Management and Budget, who keeps all the statistics in the Bureau of Labor Statistics on jobs and how much people make, how many people work in the workforce in the U.S. You can see I just pulled out part of their list of engineers. There's no system engineer there. The Office of Personnel Management also defines career occupations, and I just pulled out from their engineering list. These are all the engineers that they recognize as needing competencies. Systems engineering isn't there. So that is a problem as far as I was concerned, and something I was happy to find a sponsor who was willing to fund me to be able to find out what those competencies are. A couple of bigger picture context things that in 1989, U.S. The legislature in the United States decided that we needed to have some documentation on improving the defense acquisition workforce, meaning acquisition means purchasing and designing and developing all this warfighting equipment, aircraft, ships, submarines, things like that. That workforce in 2015 consists of 156,000 people. So there are a lot of people that have to have these skills to work in this defense acquisition workforce. Then in 2006, again, Congress in the U.S. legislated that Department of Defense needed to create a plan and a structure to be able to do competency-based selection factors. So that meant now DoD was forced to do this by law and develop this whole structure of a strategic human capital planning in them. So in the overall structure that DoD has, they put out instructions, they have a framework that starts with high-level competencies, things like leadership and communications and being able to write, that everybody needs to have, to getting down to some primary occupational competencies like being an engineer, being an accountant, being a financial manager, those type of things, and then other sub-competencies down here, and created a structure for everyone to live to identify the competency title, definition, and the proficiency levels that had to be defined, and then what kind of job tasks were necessary to map to those competencies. Now, this is just the overall overarching structure. It just ends up that in looking at those primary occupational competencies, as I mentioned, a lot of engineers, but no systems engineering. Systems engineering was relegated to being sort of a tier 3 or a tier 4, very low-level competency that wasn't defined anywhere. So I found that there were some people in the Pentagon that were very interested in defining these, and eventually got to the point of being able to help define those. So this is an example of a tier 1 high-level competency that means that in the federal government, anyone can expect in a job that you would have some leadership competencies, and they can hire you on that, and they can evaluate you on that, and they can promote you based on that. So they start with basic competencies as somebody who starts the job. Your leadership is really being able to lead yourself, be able to get to work, be able to at least get to your job. You have some interpersonal skills. You can write. You can communicate orally. Eventually, you get to the point of being more of a little bit more experienced, and you can do team building and influence and negotiating, and eventually get up to the point of being able to, at the highest level, lead an entire organization. So this is just an example of competency that is overarching on a lot of the different competencies in the structure. So now to get right into systems engineering and a little bit of history there. One of the first documented systems engineering competency frameworks that started to define most knowledge, skills, and abilities that were required of systems engineers was in COSI, the International Council on Systems Engineering. The UK chapter of INCOSI published in 2010 a systems engineering competency framework. And it was very comprehensive on what they expect systems engineers to be able to do. In the UK, there's a way of chartering engineers very similar to what professional engineering licensing we have here in the US. Since they had that framework there, they needed a competency model to underpin it. So we started to work in a collaboration. I started work on a team with this National Defense Industrial Association, which was all a lot of defense contractors and industry. Had an education and training working group that I started working on, and collaborating with the INCOSE working group to try to gather industrial competency models from different areas, and then try to harmonize these together to see, we've got all these pieces of competency models, let's put one together to try to develop one competency framework that would also be useful to all these different organizations that have competency models, places like MITRE and NASA. We also had Boeing, things like that, contributing in this, also looking for something to get out of it. Okay, now what does a competency model look like? I just want to start again with a more generic example. This is an example of something called the engineering competency model. This doesn't have the level of an official competency model that is used by some organization or company, but it's published as a reference. The U.S. Department of Labor and the U.S. Department of Commerce publish competency models, again, for just about every career you can think of. And this one was developed by an organization called the American Association of Engineering Societies, which is overarching on professional societies. So they had members from IEEE, ASME, chemical engineering societies, all these different societies contributing expertise on what do engineers need to know to do the job of engineering. So they kind of structured their pyramids, all of them, from personal effectiveness up to very job-specific competencies. So this one, I'm just giving you an example in something you might recognize. I try to pull out some examples of things that are in that competency model. This one is our specific categories they have on things like interpersonal skills. I don't know if you're taking these Principles of Project Leadership course, if any of you are taking that course or have taken it. I know that there's a lot of work in that course on teamwork and interpersonal skills and how to address those in the workplace. There's also how you understand what clients and stakeholders and customers need. And I pulled out some examples of systems engineering competencies that are in this engineering competency model. Just to show what statements, as elemental kind of statements there are in these, it's just a bunch of statements that are put in ways that you can sort of actually identify what somebody would have to do and perhaps maybe assess them on how they could do it. And I just pulled a partial list of things related to design, be able to understand project requirements and analyze manufacturing, consider human factors, use engineering software. So these are pretty straightforward competencies and knowledge, skills, and abilities you'd expect of a system engineer. Just wanted to pull out some examples of what they have in more specific aspects related to interpersonal skills. They expect that you would show sincere interest in others and their concerns and demonstrate sensitivity to feelings when you're working with people. Recognize when relationships are strained, show understandings of others' behavior. So these things are all things that they expect engineers to be able to do in their career. Working as a team, you can serve as a leader or follower, encourage others, exhibit tact and diplomacy, deliver feedback and constructive criticism. Again, these are all things that you might not expect in an engineering set of competencies, but because it's now documented, when companies are looking at this, they can refer to it and say, we want some of this in our people that we hire. Now I want to switch to a couple of studies that were done around these areas. First one was a study of the 38,000 member defense acquisition engineering workforce. As I mentioned, there's 156,000 people in the entire defense systems acquisition workforce. 38,000 of them are more or less engineers working in the areas of system development. They were surveyed to ask them, of all the competencies identified for system engineers, which ones do you have to be most proficient in to do your job on a day-to-day basis? And which ones are most critical to getting your job done as trying to develop the mission objective of what you're working on. So anything that's in the top right up there means that you have to be very proficient, and it's critical to your mission in getting your job done. I thought the interesting thing is that all of the technical competencies in systems engineering were down here to the lower left, but in the upper right, the top 3 things that these people thought they needed on their job every day and were critical were communications, ethics, and problem solving. Now, they're very general, but it's just surprising that they actually think that these kind of skills are what's the most useful for them. Not that these aren't useful, but there's the, that these kind of things are important in doing their job. Next survey, a separate survey, was done by Professor Rob Newowner at the U.S. Naval Academy, the Naval Air Systems Command, where they develop all the designs for aircraft for all of the U.S. Navy. He surveyed their systems engineering hiring managers, people who write job descriptions and have the authority to hire people into the organization as system engineers. And he wanted to know, what type of skill proficiency are you looking for with higher proficiency to the right on a new hire and somebody who's mid-career, say 3 to 8 years into their job? Anything to the right is more important. And this was independent of that other survey. Communications, professional skills, personal skills, and teamwork, the top 4 skills that NavAir was looking at when they hired people. All the technical skills down here, they feel they need them, but they felt like if they saw you coming out of a university somewhere, you probably had the technical skills, you didn't get through there. But these are the skills that made a difference in getting your job done and working with people and being effective. Because systems engineers need to work with other people, and they can't do it yourself. By mid-career, teamwork became even more important. Problem solving became more important. Systems thinking became more important, and things like being able to work at conceiving designs at the earliest stage also increased in importance. So just interesting, again, that these kind of skills for system engineers came across not just as technical, but also in the areas of communication. So just 2 snapshots of surveys of a broader sense of workforce in systems engineering. Now on to the project that I was worked on to develop the system engineering career competency model for the Navy. The sponsor on this acronym over here, Deputy Assistant Secretary of the Navy for Research, Development, Test, and Evaluation. They are essentially the chief engineer of the entire Navy, in charge of all of the research and engineering enterprise for the entire Navy. And what she wanted was to understand just what do my system engineers do. I want to know in very explicit, objective terms what they need to do. I mean, I know what they're doing something, they're doing a good job, but I really want to know what they do. And I refer to this kind of quote here that, in theory, there's no difference between theory and practice, but in practice there is. So the whole thing is that everybody who was educating or using systems engineers could have this idea of what they thought systems engineers were and could hire them, but she wanted to know if they have specific skills, I want to have a competency model where people can actually require them to have those skills. It didn't exist. I want to make sure that I can promote them based on those skills. And if I have to, fire them if they don't have those skills. Until this model was created, that was not possible for systems engineers. It was possible for all those other engineers, but not system engineers. So what we had to do is survey the community of defense systems engineers and do it in such a way that we could get the model approved at that level to now require these kind of skills in systems engineering. So as the engineering competency model was a competency model, we developed a system engineering career competency model is what it became known as. It was based on the original defense systems engineering competency model, which was the basis of that survey that I showed with that chart on there earlier. We had to develop a verified set of systems engineering competencies that met in accordance with this Uniform Guidelines on Employee Selection Procedures, because that was the document that said, if you conform to this, then you can actually use those competencies for human resource functions. You can hire people on it, you can promote them on it, and do other kinds of functions. So we organized a survey to try to understand what systems engineers do. took quite a while to get the survey because we had to pull together existing resources of the job postings, job position descriptions across a number of different services and collect what it is people were looking for in systems engineers, put that into a beginning point of what defines systems engineers. We then had to identify practitioners of systems engineering and supervisors of systems engineering and subject matter experts to organize them into panels, to try to interact with them, to try to develop the basis and the content of these models. We had to get an IRB permission because it was considered human subject research. Had to get it through my institution as well as the Navy as well as Department of Defense. That took 1 year to get that approval. We worked on other things while we were doing it, but still, it took with that much enterprise-wide aspects. I don't know how many of you are working on research on human subjects that have to do an IRB, but it was a major IRB. We also needed union approval because unions were looking at this as to make sure that if you collect information about somebody and how they do their job and you're going to make a job decision on whether to hire or fire them, the union wants to make sure you're being fair and you're doing it the right way, you're collecting that information and you're going to use it appropriately. So it, again, took about a year to get union approval. So we had those two things going on at the same time. We were organizing these panels and collecting information. So we then created a survey that we deployed to about 7,486 systems engineers. Part of the problem was because systems engineers weren't identified, we didn't know who they were. So we had to go to these organizations who hired all their engineers, and they had to look through their people on the job and say, who's a system engineer? Who do we include in the population? We didn't know what the population was. We wanted people who were doing system engineering now, not somebody who had done it 10 years ago and has never done it since. They had to have at least 6 months of experience as a supervisor to be considered a supervisor, and they had to self-identify as a system engineer. So we had this huge oversample of people, and a lot of the surveys didn't get completed because people would say, I haven't done systems engineering. No, I'm not doing systems engineering now. No, I'm not a supervisor for 6 months, and things like that. So we did get a pretty robust response rate that represented what we thought was representative of the population, even though we didn't know the population at first. By the time we got the survey responses, we had a better idea of what was our surveyed population that we were looking at. So what we did is we asked people to rate the different tasks they do on the job. So the people who were practitioners and did systems engineering would list the tasks they do. Then their supervisors would have to look at it and make sure those actually were the tasks they do and that's what they expected them to do. And that they were doing it well enough to be considered a system engineer. So the supervisor could make it that particular response either didn't count or work with their workforce on it. So at any rate, we got them to rate the different tasks and competencies, and also wanted to try to identify what's required at entry into that job. Now this is a resulting model. I'm not showing this for any other reason, just to show that there's a different spread of competencies. These are just the titles here. So we have things on technical management that typically have to do with project management of systems. The sort of business acumen is, we kind of categorize that group. Things like being able to do cost estimating, negotiating, contracting, that kind of thing. The analytical, or the very technical things related to systems engineering. These different areas of requirements and verification, doing architecture, things like that. And then the professional ones, as we call them, with communication, interpersonal skills, things like that. So came up with 44 competencies and 179 tasks that were sprinkled throughout this as subtasks that went under these competencies here. So as we looked at, this is an example of one of them. Just to give you an idea what the contents look like, it would have a competency title, a description, this one mission level assessment. If it were a typical company, that would be the business level assessment. And then these are the different tasks, meaning what do they do on the job, that they have to be able to analyze gaps, they have to analyze requirements, analyze a solution space, conduct trade analysis. So this is a typical kind of things engineers do anyway, but these are the specific things under this particular competency. Some other competencies, again, just for reference, technical ones, architecture design, very core to systems engineering these days, being able to develop an architecture and work with architectural models. Aspects of leading teams, managing stakeholders, meaning the stakeholders are who you're developing the system for, other people that have a major stake in developing that system, looking at requirements definition, and then of course the communications and personal skills. These are just definitions of some of those competencies that exist in that model. Now, looking at a breakdown of the different services, those tasks that were the subtasks under that competency I showed on mission assessment had a few tasks. As I said, there were 179 total tasks that went across all the competencies. We also asked in the survey which ones are critical to doing your job and at what level of your career experience is it critical. And somewhat interesting, you can see that the Navy and the Missile Defense Agency, this blue and gold here, Missile Defense Agency are the ones that do actual missile defense systems for the U.S. military. They're not really military service, but they're sort of what's called fourth estate, people working on military systems. Very similar approaches to their criticality of tasks. GS 7 and 9 is when you get hired and you're a system engineer who just started. Notice there aren't very many things in your early career stage that are super critical to doing your job. But as you get up to promoted to a GS 12, where you're pretty much considered to be able, an engineer can work on your own, especially around GS 13, you're actually starting to supervise people. So you see that 3 of these organizations, Army, Missile Defense Agency, and Navy, don't tend to give much responsibility to their early career people. The more senior people do it, but the Air Force was giving much more responsibility to early grade people in systems engineering. So they just kind of stuck out as being a little bit different in their approach to systems engineering. Nothing wrong with that. It's just that they expect more new hires and junior people to be able to do more systems engineering. Another thing that came out of this is all 179 tasks came out to be critical in some way to accomplishment of the job of systems engineering. Part of that was due to the fact that these panels that worked on developing the survey narrowed down these different tasks under each competency to as small a number as they could before they implemented the survey. So it wasn't surprising that all these panels of experts said these are critical tasks, and they had to narrow it down to 179 across all of them. They just couldn't go any further, and it just proved them right that they were the tasks that were most critical. But again, they were subject matter experts. I expect they should have known it. So now, just an idea that some of you are probably working with the Systems Engineering Handbook. I know it's part of the context for the 5100 class. Just to give you an idea that what we did is we checked the competencies, try to map them against the Systems Engineering Handbook, which is not used in Department of Defense, just to see if we cover aspects related to a standard handbook. And we found that we did cover many of those competencies, covered aspects related to what's documented in the handbook as it approaches systems engineering. We had a gap, though, not much in model-based systems engineering, but again, this survey was conducted around 2015. So not a lot of detailed model-based systems engineering like you can do today in there. And a couple other areas not really covered, but they aren't core to systems engineering. So as a result, the implications for that is that now the Department of the Navy has deployed this as a digital network of competencies, so that they can now just take their USA jobs, where you go look for a job in the Navy. They publish all the job openings for the entire Navy. Their back end for that is called USA Staffing. So in their database, they've included this competency network, so hiring managers who are looking to hire people can just put those competencies in the job, and they'll show up in the USA jobs area, so that when people are looking to hire someone, they know what systems engineering competencies are necessary. DoD can now require those tasks for the first time. As I mentioned before, you could only highly desire systems engineering skills. You couldn't require it. So now you can for anyone in DoD as far as that goes. So I want to talk about the next project that I worked on, separate from that defense project, but I've been working with INCOSI as the chair of the competency working group to develop this competency framework and competency assessment guide. Competency framework published in 2018. This guide will be published in January. It's just to give you an idea of the types of things that are in this systems engineering competency framework. This one is more general than the U.S. Department of Defense. This is an international collaboration of systems engineers to look at internationally what are the important system engineering competencies. So this one I appreciated to work on once I finished the other project in around 2017, 2018 to transition and work on this, so there was a much more international participation in developing a competency model as to what system engineers need to know. As an example, it has a bunch of tables in it, this competency framework. One table per page talks about a description of the competency, why the competency matters, the different proficiencies from supervised practitioners where you're generally hired into a job, and as you go up to becoming an expert in an area, competencies become more complicated and deep. And each of these are called knowledge, skill, ability, and behavior statements that are individual items that people would exhibit, let's say, for systems thinking. Now, it's not expected you know all of these, but a particular company or organization, they would pick out the ones that they think are the most important for your job as you define those. The Systems Engineering Competency Assessment Guide, which is this companion publication that's going to be coming out, published in January. Here's just one example to show that they added indicators of their competence are these elements of these knowledge, skill, and ability statements. And then they have aspects related to how you can assess whether somebody has it. And now it's documented, so there's a place to go. So if people are looking at how to assess what you're doing on your job or whether they want to hire you, they have a resource to be able to say, how do I assess somebody to know that they have the skills to be a system engineer? Okay, yet another competency model project that I worked on was to look at the future of what kind of skills would be necessary in the future, because we're moving to a much more digital-based aspect of modeling, using systems modeling tools. We have a lot of things we're saving as data. Models exist digitally. We don't print blueprints of things anymore. We have digital models and a lot of digital information. So how are we going to deal with systems engineering in a digital environment? So we went through, again, some of these competency models and frameworks to try to pull together information that we could find, and developed what was called the Digital Engineering Competency Framework, where we looked at aspects related to data and digital aspects. We tried to leave out the fundamental systems engineering stuff that was already documented and just go into the digital area. But you can see they added things like software literacy, data analytics, artificial intelligence and machine learning, aspects related to digital environment support, digital environment security, and things like model-based systems engineering. So these were things that were not part of the competency model that Department of Defense wanted to know what should we be thinking of in the future. This is just one example of that table there. This one happens to be model-based systems engineering. So this is what one area of model-based systems engineering that Department of Defense is looking at trying to then create as a context for education and training for organizations to start bringing in systems engineers that understand model-based systems engineering, which was not covered in previous competency models. So again, looking at the technologies here, there was a lot of subjective opinion on what's important to go into a digital competency model. Things like digital thread, digital twins, where you have a digital model that can reflect what the operational system is. So you run the digital model, and then you can look for problems, and you can look at the operational system, and you can actually run them together. The simulation model running while the operational system is running. In aircraft, they do that today with aircraft engines. They can flag the aircraft if there's a problem because the digital model and the simulation in real time is saying that given the situation where you are, you could be headed for a problem, things like that. But they expect digital twins to be a standard way of doing business. In the future, in systems engineering, things like a digital thread, which is connecting the digital model all the way up to the engineering detailed analysis and back into the model, so you can actually extract. Your engineering analysis comes from the model, the actual model, not just some abstraction of the model you think you need to analyze for structural strength or fluid dynamics or whatever that is. And then digital artifacts. You don't have paper to sign anymore. If you're going to certify an aircraft to fly and you're going to do it with a digital model and you're going to sign it in digital form, what does that artifact look like? And where does it get stored? And how do I know that who signed it? Those kind of things. So it ended up that we thought that these weren't individual competencies, but these were collections of competencies around these ideas. And so it just ended up that you could thread through the model and find that if you wanted competencies to work with digital artifacts or digital twins or digital thread, that you would have to find your way through that model in order to identify what those were. One of the things we tried to do in developing this digital engineering competency framework was actually not just talk the talk, but walk the walk. So we developed a SysML model of this framework and put all the elements of this model into that, worked it into something called the model-based engineering environment, the open MBE structure, so that we had the model. We had a model repository in the cloud. We used Amazon Web Services. And then we had something called a view editor, which allowed someone to view the model, but not have to have access to the model. So they can actually look at the different diagrams, but they have no permission to change anything, but they can view any aspect of the model that they want and then print it as a PDF. So it provides this structure for people to work in an enterprise on a model and yet not have people messing up the model who don't know what they're doing in the model. So we actually published this on a GitHub. If anybody is that interested to know what this model is, it was created in Magic Draw Cameo because a couple of years ago. I know it's been bought by CATIA, and now it's a different name. But it's a file that we looked at to try to not just develop the model in a digital form, but also be able to test out this idea of the model-based, the open MBE, to be able to access models, and then have people who don't use models access those and have a structure for that as a test of how we might even be doing digital engineering in the near future. So I want to kind of get to the end here on talking about the implications for education. As I mentioned at the beginning, competency frameworks provide that context in their content to be able to look at how you can develop systems-related skills because they've been identified and now they can be worked into curriculum at different undergraduate and graduate levels, as well as in companies, to say this is what we need for competencies in our organizations. And we can use frameworks for competency-based education because, as I said, the U.S. government's requiring competency-based aspects related to hiring and managing people, so we can look at understanding how we need to educate people to get there. ABET has recognized systems engineering as a accreditable discipline for several decades, but they have both the undergraduate and the graduate program. There are only 3 graduate programs accredited at the ABET level, the master's level. That's Air Force Institute of Technology, the Naval Postgraduate School where I was, and Johns Hopkins University, the only 3 universities at the master's level. There are a dozen or a couple dozen that are accredited at the systems engineering at the undergraduate level. But ABET, very recently, in the 2019 and 2020 accreditation cycle, added aspects related to systems engineering to all engineering accreditation. So you had to address aspects related to system in some way in all engineering criteria. And just last December, ABET accredited program criteria that are specific to degrees awarded in systems engineering. So I was a member of a working group that helped develop that. Probably took several years to get that through ABET to be approved. But starting this year in accreditation cycles, any program that's going to be accredited in systems engineering has to have meet these program criteria. And now that we have these competency models, schools can look at what do they need to teach in that to get there. That engineering competency model that I mentioned has a set of worksheets in there as spreadsheets you can download, so that if educators want to look at, am I teaching the right thing, they can pull these competencies right out of the spreadsheet and put them into how they want to get them into their courses. So they have a spreadsheet that they can just pick and choose as a set of learning objectives that were vetted, as I said, by a lot of professional organizations that these engineers in the workforce sort of align to. I'm going to show this one that in working on that competency standard, as a member of the working group for IEEE on that defining competency standard, another work aspect that I worked with, one of the groups in there were physicians. And they were interested in what kind of competencies would be necessary for physicians to be given their ability to be able to be sort of certified as a medical doctor in different competencies. So I took one example. The way they organize their competencies are around what they call the critical and trustable professional activities, things like a doctor has to be able to do in the context of a more holistic look at the context of what they're doing, not just little individual statements, but much more holistically, where these are sourced from all kinds of different places into their competency models. And this is done by the American Medical Association and published so that medical schools will start using this as a basis for competency development, so that as you need to do functions related to the competencies as a doctor, the different behaviors that you have to do as a doctor. If you're rated in here, you're developing, but you're not there yet, you have to be at this level to be entrusted, which means you can actually be trusted to be a doctor. The other thing that physicians have is that once you get here, you have to maintain your proficiency. If you don't do this for a while, you start to go this way, and you're going to have to prove yourself again and build your certification up, so they realize that it's not a static thing. It's just like any kind of a pilot, commercial pilot or a private pilot. Every 90 days, you have to land a plane 3 times and take off a plane 3 times successfully in order to maintain your active certification. Doctors have the same thing. They have to maintain their ability to be certified as a doctor. As I mentioned, there's a IEEE standard that just got approved this week, should be published very shortly, which is now a standard on how you define competencies, which will provide much more structure on how competency models can be defined, and a companion standard from IEEE on data models for reusable competency definitions, so that competency definitions that are out there, that you can search for them, discover them, and pull them together by searching for them on the internet. I'm also a member of a committee to develop software and systems engineering certification competencies for the International Standards Organization. So in summary, just a kind of an overall historical perspective of systems engineering and then development of specific competencies required of system engineers and what they need to know and what they need to do. It's only been very recently that this has been documented in some way that we have an understanding with some statistically analyzed surveys to understand what those competencies are, starting with Department of Defense and pushing them out internationally, and then in January getting it published to the overall audience. Right now these competency frameworks are available to INCOSE members, and if somebody knew that they were there, they could find them, but they're kind of behind their paywall, INCOSE members. So now it'll be out to the general public in the form of a book, and later as a database. This month, as I mentioned, in this INCOSE Insight Professional magazine, should be published any day now. I co-authored an article on how to use competency models in general, which will be coming out soon. At the end of the presentation, I included this. These are all different competency models for different kinds of, all kinds of different areas. Just a point of reference for anyone who might be interested in where these different kind of competency models come from. That each one of these does include a particular competency model in a particular area or over a wide area. So, again, thanks again for your time. I'll entertain any questions, or if you,
maybe you don't know this, maybe this isn't what you were studying, but is there a way you would recommend to people trying to get jobs to demonstrate to recruiters that they have these competencies and skills?
Yeah, I think the question was on looking at recruiters and trying to, let's say, impress them or let them know that you have certain skills. I think at least the competency, being familiar with some of the competencies in the framework and the things that you've learned, you might be able to reinforce that these are the things that, let's say, in COSI, as the International Council on Systems Engineering, thinks are important, and I have these skills. If you're interested in working in systems engineering, or you have a company that you know is interested in systems engineering, it can be useful to point out that you're familiar with the competency models and the competency framework, and you see from your classes you've developed the kind of competencies they're looking for. If you're working in a specific organization that publishes their competency model, like NASA, you can see the competencies they're looking for. If you're looking for competencies for U.S. government, those things, you can find that model, you can see what U.S. government organizations are looking for, and you can be much more specific. But as I said, many companies consider that to be either their intellectual property, that they develop this competency model, that they hire people and they promote them based on these competencies. Or we also ran into a problem with legal considerations where company lawyers didn't want that competency model going out into the public and then somebody messing up a system engineering situation, and then they'd go back and sue the company and say, oh, you gave us this competency model and we followed it and we failed, and therefore we're suing you for saying you had a good competency model. So we had a few things to deal with there, but I think for the most part, if you tie those things from your education into the things you'd like to do. Or you can also look at it as what kind of skills are they looking for, and what could I look at trying to develop in myself while I'm in an education program that can offer these kind of things, and see if you can match up those skills that way. In fact, some of these studies that we just recently put out, we looked at job postings on Indeed.com and another job posting site. I can't remember the name of it. What's that?
Handbook?
Yeah. I don't think it was Handshake, but there's another one to see what we could find for these kind of skills. And there's quite a number of companies that are looking for these kind of skills in job advertisements. Yes, was there a question on the question?
Just I have a question. Can you hear me?
Yes.
Okay. So it's actually not the question, is more like an observation. So I saw the competence that has been and the work that you've done before in defining competence for systems engineers embedded into OPM and the DoD in the earlier slides. My question and my observation is, if they are well defined, the interface to the talent is not completely clear. What I mean is, if I go to USA Jobs and look for, say, GS13, GS14 systems engineer, I will never find a job. Apparently, they put that under 0801 or 0800, which is either a general engineer or interdisciplinary engineer. So new graduate students want to work for the government. There's no like an MOS specifically code for systems engineer in order for them to get a shot, and then they can get evaluated for their competence or not. There's no clear path to get in.
Yeah, if I can paraphrase, I guess you say if you're looking at the different engineering occupational series categories of 0801, let's say general engineer, or whatever number for electrical engineer, network engineer, whatever it is, you can find the specific competencies and what is expected in that. But for systems engineering, it just doesn't exist anywhere for you as somebody who's looking for a job. But what the competency models were for was the hiring managers and HR people to start putting systems competencies in there, so they're not restricted, at least in the Navy, of living just with those competencies from the occupational series, that they can add systems competencies to that and do that with confidence that they can actually include that in their hiring. But then those systems competencies should show up in that job description or position description in some way. So there's no way sort of generally, I guess, to prepare for that and look at these and target these. You'd have to look at it in one job at a time and try to recognize that what they have in their advertisement is something that's related to systems, that you could then find, you could go back yourself to find out more detail about what that competency is entailed in, or how they might assess it.
Thank you.
And I will say, though, that you mentioned talent there. I think on this competency standard development for IEEE, the vast majority of people were not electrical engineers. They were people in the field of talent management. And there was a big participation of people on this, because talent management is what organizations do to try to structure how they organize things around competencies today. And so when that standard is published, it does talk a lot about how these things relate to talent management and both ends of the spectrum, people who hire, people who are looking for jobs. Yes?
Have you found that there's like a company size in which companies start to develop these competency models, either internally or start using an external competency model? Because I imagine small companies don't find it worthwhile,
Right.
but then obviously 100,000 employees, you start having.
Yeah, no, that's, the question is there, did I see anything about different size of companies that related to the development of competency models? And really, the only companies we found that had competency models were big companies, Raytheon, Boeing, things like that, where they, especially were doing a lot of defense work, so they could show that they had these competencies. One of the things that smaller companies wanted was a resource that they could go to and find competencies. And a lot of them went to NASA Apple because that is their model online and they could try to translate it into what they needed. But that's why they were also organizations like that were interested to work with INCOSE to at least define those. So a small company could then pull the few competencies they want into their job descriptions. And they just don't have that human resources infrastructure to need that. But that's one of the value propositions we had in developing this and making it available to many different companies. Yes?
So we talked a lot about competencies and how your management assesses you for promotion, correct?
Yes.
But at the same time, is there any way we can do a self-assessment to see where we stand on the competency?
Okay, yeah, that's a good question on the assessment of competencies from a self-assessment. Having a competency assessment guide lists the competency, the knowledge, skill, or ability statement, and then it lists ways that people can assess someone on that. So you could self-assess by going through that entire 400 or 500 page book and looking at these, but that's kind of excessive. So what INCOSE is developing is called the Professional Development Portal. And they are going to use the competency framework as the structure for that, so people can self-assess on competencies to see where you are with different competencies. INCOSE is also going to transition to a certification basis for certifying system engineers based on competency and going away from just the handbook. So this professional development portal has taken the competency framework and put it in a database format. So if you want to assess yourself on competencies, you should be able to do that by picking the competencies and then being able to self-assess. And they don't have that full capability up yet. But once they have this assessment guide there, then you can pick and choose by picking them out there. I want to know how to develop these at a certain level. Like maybe I'm entry level and I want to be at practitioner level. You can start picking them and assess yourself as to how you're progressing on towards your proficiency or your goals for your career on proficiency.
That was actually my next question, actually. Tailored help guys that could help us. Is there any other, but just ask that question as well, right?
Well, thank you very much.